National Standards Institute. It is the standard language for relational database management systems. That's just a fancy way of saying databases, relational databases. Some history, SQL was initially developed at IBM in the early 70s by Donald Chamberlain and Raymond Boyce. In 1979, the company that is now referred to as Oracle introduced the first commercially available implementation of SQL. Today, SQL is everywhere. All jobs working with databases are going to use SQL. And it's really important to learn how to code in SQL. It'll help you in your job search, and it'll just open up more opportunities. So a database is the persistence layer which contains a set of data. And that just means that the data in the database is persistent. If you refresh a web page or change states, the data is going to be the same. A relational database is a database structured to recognize sets of data as well as the relations among the stored data. So the database consists of a set of tables with data as well as relationships between the different tables. So we can think of a data model for a store. All of the customer information would be stored in a customer table, and all of the products would be stored in a product table. Both of those tables live within the database. And there would probably also be an orders table, which would contain information from both the customer as well as the product which they ordered. So a relational database, tables, relationships, and data types. Relational database categorizes similar sets of data into tables, and each table will have a relationship to another table, often many tables, within the database. The relationship between tables is what makes the database a relational database. The process of organizing columns and tables in a relational database is called database normalization, and its main purpose is to reduce data redundancy and improve data integrity. So there are a few different relationships, and we'll go over the one-to-one relationships, one-to-many or many-to-one, and many-to-many. If we think about a store, a data model for a store, we can start to kind of understand the relationships. A single store can have many products. That is one-to-many. They can also have many customers. That is also one-to-many. The customer table would have a many-to-many relationship to the product table, meaning many customers, meaning one customer can have many products and many products can have many customers. There would also be an orders table, which would serve as the connecting table for customers and products. It would contain the customer ID as well as the product ID and maybe some other data, some other data. This is often referred to as the bridge table, mapping table, cross-reference table, join table.
Can you just make the text bigger, like zoom in?
I'm not sure if you can zoom in.
Like the view or something. Oh, never mind.
I don't think it's going to work.
No, I think you can
Okay,
zoom
I don't know.
That might help. Okay, and then an example of a one-to-one relationship would be if we created a separate table to contain the customer addresses. One customer would have one address, and one address would belong to one customer. So tables, each table is made up of columns and rows of data, somewhat like a grid, and columns go from left to right, and the rows are from top to bottom, obviously. Each row is a new set of data in that table. And within tables, we have something called primary keys and foreign keys. So each table needs a primary key, which is basically a unique ID. A primary key is a field in a table which uniquely identifies each row or record in the database table. Primary keys must contain unique values, and they cannot be null. Foreign keys are used to link two tables together. A foreign key is a column whose value matches a primary key in a different table. The relationship between the two tables matches the primary key in one of the tables with the foreign key in the second table. And here's kind of an example. We have a customers table, the ID would be the primary key, and in our orders table, it would also have its own primary key, and then the customer ID would be the foreign key from the customers table. And as well as data and rows and columns, we also have data types in tables. So the different types of data types we have are char. It's a character string with fixed length, where you would define the length with n. We have varchar, which is a character string as well, but the variable length can kind of change. You would put the max number in n, and depending on how many characters are actually in it, it would adapt to that. But the max length is the end value. We have Boolean, true or false. We're familiar with Booleans. Int, integer. We also have something called big int and small int. Big ints are larger numbers, obviously. I believe they're up to 19 digits. And small ints are roughly around 5 or less. We have decimals, and with the decimals, there is two values here. The x is the amount of digits to the left of the decimal, and the y would be the amount of digits to the right of the decimal. We have a date, stores dates, time, stores time, and then a date time, which kind of does both of those together. So when we create a table, the syntax kind of looks like this. You use the create table statement followed by the table name, and then in parentheses we have columns and then the data type next to the column. There are also optional constraints that you would add to the right of the data type, such as not null, primary keys, stuff like that. So an example of creating a table for students, we have the create table statement, students as the table name, and then we have columns as well as their data types. And then you can see down here, we set the primary key to the student ID, because the student ID is always going to be unique. We could have students with the same first name, the same last name, maybe the same city, probably not the same phone number. But it's good to use IDs as our primary keys. And so once we have tables in a database, we use something called queries to select and retrieve data. So a query is an inquiry to the database using the select statement. A query is used to extract data from the database in a readable format, and it returns something called a result set, and it returns it in a tabular form. So the same way how tables are kind of tabular, when we query for data, it returns in tabular form as well.
Quick question.
Yes.
To write that, pretty much the syntax, is that terminal language or is that like on a regular? Like why would we write that?
Right, so usually you can write it, in my experience, we use a program called SQL Server Management Studio, and it's a way to manage your database. And so all of your data, your tables, your rows, your columns, is within that program, and you would write your queries in there.
Oh, okay.
Are there any more common ways of where you would write queries?
No, I mean, the queries, it's not like a terminal command, it's not like, it's kind of code, right? So it's like, where do you write C#? It's really kind of anywhere, it's just a text file at the end of the day. Same thing with the query. The query is meant to be executed against the database, but where you write it, it doesn't really matter. There's some tools to help you take that and execute it against a specific database, but it's not its own thing, right? It's just a linkage.
Okay.
Okay, so some of the common queries and the ones we'll go over is the select query. That's used to select specific data from a database. We have the where clause, order by clause, insert, which is insert into, so that's when you're inserting new rows into a table. We have the update, we have the delete, select top, joins, and subqueries. And if you look, you can kind of see we have the CRUD pattern in here. The select would be the read, the insert could be the create, the update, and the delete as well. So before we get into the queries, we should probably do like a data model and kind of get to see how these relationships work. So I'm gonna go to the whiteboard. Do you guys want to do a data model for a store or like a RPG game? Store. Store, okay. So we probably have a store table, and that would probably contain ID, name, and location. And we would have a customers table. Probably also with an ID, name, phone number. What else do you think would go into a customer table? Address? That's a good one, yeah.
Recent purchases.
Okay.
Did the primary key go in there as well?
Yes, so the primary key would probably be the ID here.
Okay.
It's like a customer ID. You could write it customer ID or ID. But since we're in the customers table, I like to just go ID. We probably also have a products table. So we go products. And also have an ID, name, maybe a price, maybe category, okay. Quantity is good. Let me know if I should write large. Should I write larger? Can you guys read this?
Yeah, right larger, please.
A little bit bigger, yeah.
Okay. Started going from large to small here.
Do a great table.
Thanks. So ID, name, category, price, quantity, thank you. Quantity, and maybe in stock. This would be the primary key. Okay. Probably also have orders table, right? So put that. Can you guys see it? It's down here. Yeah. We'll have definitely the customer ID. We could have the product ID. You guys still see this? Okay, good. Want to make sure. What else do you think would go into an orders table? Okay. Yeah, that's good. We'll go time purchase.
Order summary.
Okay. Summary. So in this table, the customer ID and, well, orders probably have their own ID as well. I'll throw that in here. So in this table, the customer ID as well as the product ID would be the foreign keys. Because they are matching values from the customer ID to the orders and the product ID to the products. And then for the relation, any other tables you think we should add? Probably good for now. So the relationship from store to customers and store to products. So we're gonna have one store and many products to that store. And the same for customers. We'll have one store and many customers. And then the relationship between the customers and products would be, what do you guys think? Many customers to many products. And this orders table kind of works as our reference table, right? It has the ID from the products, the ID from the customer, as well as a few sets of its own columns. That kind of help visualize how the relationships work a little bit. Okay. So now we're going to be going over how to query into tables to get certain info, right? So I'm going to come back over here. Maybe we should actually add some data types, right? That might be good. So IDs, ints, right? Name, what do you guys think?
Car.
var car and
Okay, and what would you like so the N has to be a numerical kind of,
so it's like var car 32 should be able to fit most
Okay.
people's names.
32, and location, probably also be var car, unless they were doing some kind of like numerical representation, which then you would probably need another table to kind of correlate, but we'll keep it simple and go var car 20. ID also int, name var car 32. Phone, int, okay. I believe with integers, do you also put in a value for, no, you don't have to? Okay. Address, we could do varchar again. 20 should be okay. Recent purchase, what do you guys think? I agree. 32, in case it's a lot. ID int again. Name varchar again. Category varchar. Price, what do you guys think for the price?
Smaller.
Decimal, yeah. So we go decimal, and remember the x and y, x is the amount of digits to the left, and y is the amount of digits to the right. How pricey are our products? They're pretty pricey? So maybe like, how many digits to the left do you think? 7, okay.
Shopping at.
Apparently we're selling yachts.
And then we could probably just do 2 on the right. Quantity, it's in, okay. And then what about in stock? Boolean. Cool.
So for store, we can actually change name and location to just car, whatever the name and location would be. Since that's just the one store, we would know exactly what that is, right? It's not gonna
We
change.
could, yeah, it's not gonna be, really, yeah, we could do that. Let's do it. Okay. And typically, these rows are actually columns. Just when we're data modeling, it's easier to do it like this. But it would be something like, you know, the customer table. And then you have ID as a column, name as a column, phone, address, etc. So it's kind of like a grid, right? And then for each row, we have like new instances of all these things, right? Yeah, yeah, yeah. So that's kind of what a table looks like. And then, yeah. Okay, so we'll go over queries. So a query is an inquiry into the database using the select statement. A query is used to extract data from the database in a readable format. And the request to the database for usable product information is a typical query that is performed in a relational database. So I kind of went over some of the queries we'll go over. So the select statement retrieves data from database. The data is returned in a table-like structure called a result set, and select is the most frequently used action on the database. So the syntax, you go select column name from table. That would return specifically that column name. So if we wanted to just return the customer name, we would say select name from customer. But if we wanted to return all of the columns from a table, you use the asterisk, it's like the star symbol. You select that from the table name, and that would return all of the columns, the ID, name, phone, everything. And we can use the where clause to filter for rows that meet certain criteria. And the where clause is used with the select or the update and delete. So we do a select from column or select all from table where condition equals a value. So an example of that would be select first name, last name from students where the column cohort would be a column, equals spring 2017. And that would return the first name and last name of all students in the cohort spring 2017. And again, you can return all of the columns if you just replace this with the asterisks. And so when you query a database, it returns the data in no real specific order. I think it might be the quickest. So you kind of get it just based on how quickly it returns. And if you wanted to ensure like a specific order, you would use the order by clause. And order by allows sorting by one or more columns, and the default order is ascending, so low to high or A to Z. The syntax is as follows. You select the columns or all columns from a table, and you order by the column name. So for an example, we could use select all from students and order by last name, and that would display them alphabetically from A to Z according to their last name. So here's an example. That was the example. And then if we wanted to order them in descending order, So Z to A or high to low. All you really have to do is tack on the desk, or short for descending, after your order by column value. So that's how you kind of order your queries. We also have the insert into statement, and it is used to add new data into a database or a table in the database. Insert into can contain values for some or all of the columns, but keep in mind if your columns have values such as not null as like a condition on that column, then you have to include that column when you're inserting into the table. So syntax is pretty simple. You go insert into table name. In parentheses, you type the column names that you are inserting into, and then the values are passed in parentheses as well. So if we wanted to insert a new student with the first name, last name, and phone number column, this is kind of how it would look. Insert into students, columns we're inserting, and the values for those columns. We also have an update statement. And the update statement updates data values in a database and can update one or more records in the table. You can use the where clause to update on specific records only. So some syntax would look like update table name, and then you type set column name and set it to a value. And if there's more than one, you use commas at the end, except obviously for the last one. We've seen this before. So an example, we have the update students set in session to 0. So 0 usually returns, 0 is always going to equate to false, and 1 equates to true. So here's kind of an example. Here's an example using the where clause specifically. So in this example, we used the set in session to 0, which would return false. And here we can update the students and set their in session to 1, which is true, but only where the cohort equals spring 2017. So all other in session columns are going to be 0 still, which is false. Okay, so we also have the delete statement. And yes, question.
Jumping back up to insert.
Yes.
So you can include as many column names as you'd like, and then you just would have to follow with the correct values in the same order of those column names, right?
Correct.
Will it scream at you if you try to include values that are not of the right type?
Yes, you're going to have to follow the data type defined for those columns. So if you have, say, this in session was maybe set to a character, Y or N, it wouldn't really like that because we're passing in a Boolean essentially. So you want to follow those data types. There are ways to kind of fix that where you basically convert your statement to match the data type. So that kind of goes more along the lines of when you're mapping data from one database into another. Say you have a table in one database that has a character for in session, and you want to map it to another table that uses Boolean instead of a char. You would basically convert Y to 1 and N to 0.
Cool.
Yeah.
Is there a way to essentially look up what data type each thing is, or you just have to have a sheet to reference?
So when you're working with databases, you have access to the tables, and you can just kind of pull up the table, and it'll say in the table the data type, as well as if it's not null or some other constraints. So let's jump into the delete. So delete permanently removes records from a table, as it should. Delete can remove all records or one record or many records and you can use the where clause to delete specific records. So if you wanted to delete all records out of a table, like everything, you could just type delete and then the table name. I'll get rid of everything. To delete specific records, you use the where clause. So you hit delete the table name, and then where columns equals a value that you set. So if I wanted to delete all records of cohort spring 2016, we can go delete students where cohort equals, spring 2016. But in this example, you can delete a student where their ID is 20, specific record. Any questions so far? You guys want to whiteboard some of these selects and inserts and what have you?
Yeah.
Okay, because there's a few more and they get a little bit more complicated. So, question?
Is there any chance you could share this? Because it's kind of, I don't know, I find it hard to, like,
Read
it's
all of it.
easy piece by piece, but then to be able to remember everything.
Yeah, I can slack this out to everyone.
Awesome, cool.
Yeah. Okay, so let's do some queries. Okay. Any brave souls, or shall I demonstrate? It's all you. We probably want a purple. Okay, do it. So we probably want to keep this here, right? If we're going to use this.
Sure.
Maybe we might want to give you some room here to write on the border. Okay.
Somebody trap us.
Yeah, you're locked in
They,
now.
Literally
just,
on that
they,
level.
they distract us so we kind of skip. Like,
You notice
we're just
like-
gonna make room for you.
Lock. Okay, so return customers. Let's see.
Just say all customers.
Okay, yeah. Return all customers. Using, yeah.
Probably a good idea. That's just it, right?
Perfect. Yeah, that will select all columns from customers and return them.
Yay.
Yay. So let's select name and phone number from customers. Perfect, you just need a comma between, yep. Perfect,
You kept
okay.
them inside the same bracket.
No separate brackets. And I believe brackets aren't necessary, but they are used, it's like a common practice in my experience, because there may be sometimes you have a column name that is also a, like a, how do you say,
The reserved keyword.
yeah, reserved keyword, exactly. So we use the brackets to kind of get around that. so let's do return all customers whose name is John.
That's a big eraser. Yeah.
Almost. I see the logic here, and you got it, but the syntax is a little incorrect. So you want to, we want to return all of the customers with the name of John, and all of the columns essentially.
Okay.
Return all of the columns from customers with the name of John. So John isn't a column, it is an entry, like kind of a result.
Let's do a second bracket with John.
Not quite. You want a hint?
Yeah.
There's an equal sign in there. Perfect. Actually, the bracket is around name, and the equal sign is outside of the bracket. And I think you typically want to use like a single quotation around your value. Perfect. So that'll return all the columns from customers where their name is John. So that'll give you all of the info in our table from John. Good. Anyone else want to try? Should we have John continue? Isaac, awesome.
Job.
I suggest rubbing the eraser too.
So return me, let's see what we want. Return me the name and category columns from the products table. So we just want the names and the categories to display from the products table. Yeah. Perfect. Now return the same columns if we're out of stock on that item. I'm curious, I'm used to only using the zeros and ones, but can you query with true, false?
In certain databases, yes. In SQL Server specifically, which is what we're using and what we teach, it's a bit, so it's a 1 or 0. It only recognizes 1 or 0.
Is one being true and zero?
1 is true, 0 is false. It's true pretty much in English. JavaScript, C#, 1 is true, 0 is false.
Cool, perfect, yeah.
It's one of the reasons you look on like power switches, you know, like on a surge protector or anywhere, you have a 1 and a 0. So 1 means turn on, 0 means turn off.
IO,
It's the same kind of, same deal.
Now you will, always.
Now if I will. So I want you to display all of the phone numbers from. Let me change my favorites. I'll go city. So return all of the phone numbers from customers that live in Irvine. That's great. Let's go where they live in Irvine and their name is Isaac. Did I go over Ann's? Oh, excuse me. That's actually good where that is. Okay, so Ann's. Let's do that. Basically, you just kind of tack it on and you add another condition. So just how you had where city equals Irvine, you would go to a new line and name equals Isaac. So let me write that out for you. So we'll go select phone from customers where city equals Irvine, and then name equals two S's?
Two A's.
Two A's. Two S's?
Two A's. Like that.
Cool. So the and statement, you just kind of put it on a new line and add another condition with the value. Would anyone else like to jump up here?
That's right.
Cool. Let you choose your color. Purple. Okay. So return all the customers and order them by their last name, or by their name. So we want basically all of their info.
I'm just trying to, sure, now when it was up, I know it was select and then,
The column
The column?
Or if you want all of the columns, what do you put?
So if it's all of them, it's,
The asterisk.
the asterisks, yeah.
So that'll return all of your columns.
Okay. So the asterisks, and you said this one was column?
That one's from.
No, the asterisk basically is where you put the columns if you only want specific columns, but since we want all of the columns, we just write the asterisk.
And then you said for customer, so I know the second line, I don't remember the word, but I know that I would put for whichever column I want, I would put here.
Or whatever table you're selecting.
Okay, so,
So if you want, I can scroll down here again. So you go select column name from table name, and instead of the column name, we're using the asterisk to return all of the columns.
okay. So you said from customers,
Yep.
return, what do you want me to return? The phone number?
So I want all of the columns, so you have that, from customers and order, display them alphabetically by
Oh.
their last name, or by their name.
Okay, and does it have a default or do it have to stay?
So by default, it's alphabetically A to Z, or low to high. So that's perfect. What about if we want it to descending? Do you remember the syntax keyword there? Okay, you just put DESC.
After?
After it, yeah, with space. And usually we.
Caps?
Yeah, usually with all these keywords, we use caps, so select from, order by, descending, they're usually all caps.
You said it was D,
ESC.
like that?
C. At
C.
the end, yeah.
Oh, thanks,
Kind of like descending.
okay.
Cool. Looks perfect. So that'll return all of the columns from the customers table, and it'll display them by their name, and that's descending order now.
Alright,
Cool. So let's do another one.
okay.
So I want you to display the most expensive product if it's in stock.
Okay. You said the most expensive product, so it'd just be one.
Right. Well, I mean, it would give you, it's gonna give you all of the products, but basically what I want you to do is have the most expensive one at return at the top.
Okay. So then I could do that whole assembly, or the,
But only if it's, in stock.
okay. Let's see,
Kind of challenging. equals value.
Okay, so it would be, price.
Remember, we're checking only if it's in stock. So you want to use the in stock column right there. Cool.
So it's for the Boolean, right? But what about the most expensive items?
Right, so that's something you have to, yeah, the most expensive item should be on top of the result set. At the top of the result
Is
set.
it very tough?
No, you're doing great. I just mean when you get the result set back from your query,
Oh, okay.
I want the most expensive item to be displayed at the top and only if it's in stock.
So automatically, so I wouldn't even need to put price up here, right? I can just put return all, because if I actually wanna look at them,
Right, so
then
if
I
you,
would just order by price.
yeah, so I wasn't quite specific on this, the columns I wanted you to return. So right there would only return the price columns, but we probably would wanna see all of the information for the products, right?
Yeah.
So all of the columns.
So like that, we would be able to see all of the.
Right,
products.
this is 99% of the way there. Remember, we want the most expensive item on top. Perfect. Yeah, it's great. That was kind of a challenging one.
Yeah, it was.
Good
Didn't
job.
want to write it all.
You did great.
Thanks.
Does anyone have any questions about kind of how this runs or syntax or anything? No? Good stuff.
So what you just wrote there returns all the prices essentially in descending order as long as they're in stock.
So it basically returned all of the columns. So the ID of the product, the name, the category, the price. It returned all of those columns from the product table if it's in stock, and it returned it in descending order according to price.
If you only wanted the one most expensive item,
Okay.
uh,
So that goes into the select top statement, which we can go over now. Unless there's anyone who wants to jump on the whiteboard. Okay. We can do it again after. So select top statement returns a specified number of records. So select top is useful when working with a very large amount of data. Say you have a database and there's 20,000 entries, and you don't want all of those to return. You only want maybe 10 or 100. So where there's n, you basically replace it with a value. So if you wanted 10 results, you would go select top 10, first name, last name from students. So that would only display the top 10 first name and last name columns of students. And again, it's kind of like at the quickest, like databases, queries, they don't really have a specific order they return, it's just like the quickest. And that's why we use the order by statement as well, to order by, alphabetically or the inverse. So we could also select the top 10 rows of all columns with the asterisks from students. So that would return all of the data from students and only the top 10. And if we wanted to alphabetize them, then we would use an order by, first name, last name, whatever we wanted. So that kind of answers your question, right?
Yeah.
So that's how we can select a specific number of results to come back.
Quick question.
Yes.
Let's say you have a table with 50, let's say customers, and each day they're adding new customers. Let's say you wanted 5 last recent customers, would they be in the bottom or in the top?
In my experience, they would be at the bottom.
So you put bottom 10 or bottom 5 to get those 5?
Well, no, you would still do top 10 or top 5, but you would order by descending
Oh, okay, that makes sense.
according to their name or ID or whatever. Probably their ID, right?
Okay, yeah.
Yeah, that answers your question, Tyler?
Yeah, just if you wanna get like
Oh.
the most recent customer.
Yeah,
I-
also,
I
in
guess-
my experience, there's usually, like a timestamp in tables.
Mhm.
So you can see when the entry was made, there's usually a
Oh.
timestamp as well.
So you would just order it by that?
Mhm.
Oh, that makes sense too.
That's what I was gonna say, is most customer things have a, join this date and time,
Mhm.
so you can sort that out.
Exactly. And then we get into some kind of more complicated statements. The join statement. The join statement combines records from 2 tables based on related column values. So a query can contain one or multiple join operations, and inner join is the same as join. The keyword inner is optional. There are a few other types of joins, but we're just gonna cover the inner join. But if you wanted to look into it, there's, I believe, left join, full join, and a few others. But the syntax follows: you select the column names from the table 1, and then you join on table 2, where on column name 1 equals column name 2. It's a bit kind of technical there, but so we can select our order number, our total amount, first name and last name from the orders table, and we could join on the customer table where the order dot customer ID, which would be our foreign key, equals our customer ID. So basically what we're doing is we're ordering by the column specified in our select statement from our order table, and we're joining on the customer table where our order dot customer ID right here equals our customer ID. So you're looking for a specific customer in the order table using the foreign key to primary key relation. I know it's a bit confusing, especially first time you've seen it. It still confuses me sometimes because it can get very complicated. You can have many join statements in the same query, and you can also have subqueries, which are essentially nested queries. So a subquery is a query within a query. They're nested queries that provide data to the enclosing query, and all subqueries must be enclosed with parentheses. So it's similar to a join, except we're kind of querying inside of a query. So we could select product name, or name in our instance, from the product table where the ID in, and this is our subquery here, you select the product ID from order item where the quantity is greater than 100. So it's basically you're querying inside of a query. And we can get some exercise with that later on in our lab. Because at first I understand it's kind of like a bit to take in. So any questions so far?
Yes. So would all this be considered one database?
Yes, definitely. And I probably should have maybe enclosed it all into a big box. So that whole thing is a database, and these are all tables within the database, and these kind of connecting lines are the relationships between the tables. And that's pretty much what a relational database is.
And could other databases not other databases? In the sense, like, for example, let's say Target, right? Target has one big database, and each database there's like one store. So let's say store ID one where it's the same Fullerton, and let's say the store ID for Santa Ana's two.
Right.
You know, can they talk to each other, or is it, how would that go about?
So,
Target being a big database.
yeah, I'm curious, do you think separate stores would have separate databases, or is it kind of one massive database?
It could be done either way. So
Okay.
you have something called a multi-tenant database. So you can essentially, like in this instance, they both be in the same database. You have a store table that has a list of stores, right? So you have store one and store two, and then each of your products, customers, and orders has some relation to that store, right? So you know what store they're in based on the store ID for that product, right? So they'd all be in the same database.
Oh, okay, yeah, that makes sense.
But for various reasons like performance or security or something like that, sometimes you wanna separate it out. So you'd have two separate databases, the exact same schema, right? So the same tables, same columns, but this one's for, you know, the Irvine store, this one's for Mission Viejo store, whatever it is. And you separate those out, you can, but oftentimes it's really not necessary, just keep them all in that same database.
So, questions, how you guys feel comfortable, wanna go over some more, data modeling, the database? Maybe an RPG one, just to get some more experience. Okay, does anyone wanna volunteer? You want me to do it?
Sean.
Sean, Sean, you've been nominated.
He's the king.
You've been voluntold.
Sean is owning it up. Like, no, I don't know about that. What about you, John, since you nominated him?
I mean, I've already taken a turn up there, I don't wanna
He'd
steal
love
the
to,
time from
actually, I
anybody
think,
else.
yeah.
Okay. We could just kinda do it
I'll go
together.
up if nobody's wanting to, are you?
Oh,
It's
yeah.
up to you, you don't have to, it's up to you.
Well, I thought you were all standing around waiting for someone to volunteer, are we not?
Wait,
It's-
I don't
We're
really
waiting for you to
have
volunteer,
the
Alicia.
desire to.
We're waiting for you.
Yeah, okay.
There's no pressure, you're not forced.
Okay.
Yeah, I'll let you also choose. Okay, so we'll start off with an instance of a game. So a game would be a table, right?
Okay, so game?
Yeah, let's start with that, and then I'll kind of, we can all contribute. And so what do you think would be in a game instance?
ID, for sure.
An ID for sure, yep. Probably be the primary key as well.
Are we doing our columns, or are we just doing?
That's fine, if we're just doing data models, it's okay to do rows.
You have protagonists or characters.
Well, this is just a table for a game instance. Those will all be like their own
Their own
tables
tables.
within the instance.
Okay, so the game's not gonna have like
It's
the
the
name of
primary.
each table in it.
That's what you call it?
They'll
Okay.
be separate.
They'll be, yeah, but they'll have relations.
Whether you win or lose. I don't
Okay.
know.
Okay,
Uh,
win, boss,
Sure.
how about win as a boolean?
Name.
Oh, name. That probably should be up here, but, yeah,
That's okay.
Category probably.
and that's a,
Well, let's
Genre.
assume we're doing an RPG game.
Alright.
Is that okay with everyone? Maybe,
so this is a character, CHAR.
you could do that. Yeah. Maybe Vartar might be a little bit more,
Specific.
appropriate, yeah. And then maybe like a server IP. Basically an address.
Okay, like, oh, an IP address.
Yeah. Okay, I think that's pretty good for a game instance.
And that is Varchar as well? Or is that
Well, since,
Cause it's got both.
yeah, let's
Right.
just, could you pass in decimals into Varchar? Like, could you,
Yeah,
like a string, right?
it's just a string.
Okay, so let's do Varchar, cause there's usually decimals in an IP address, right?
Right.
So it's a little confusing, but I think varchar is good. And with the varchar, we usually have like a number in parentheses next to
Mhm.
it, so
name, I don't know, what, 20?
That's fine, yeah.
IP, I'm not sure how many in IP address. Is it like 14 or something? I don't know.
10 to 12, I think maybe 12. I'm not sure if you would include the port or whatnot. Cool. What else, what other table, like, one more table do you guys think?
Characters,
Okay, maybe like a heroes?
Heroes? One hero? Heroes? Is it?
Heroes.
What? With IDs?
If they would have IDs.
So like you,
So this is just one hero, right?
Well, no, it's the.
hero.
No,
It's the
heroes,
table.
that's true,
Like
okay.
you would,
Right, you're right. ID
name,
name?
level,
Level?
health, and strength.
Health? Or strength, or both?
Both would probably be good.
Weapon.
Weapon.
and armor.
Haven't we done this before?
No. We've done it 3 times.
Yeah, at least. Okay, so ID is what?
Date, undefeated.
Name?
Point.
Level? That's it. Health? Weapon. Armor, is that another int? Or we do it that way, or it's a name, armor name?
And the health levels are probably was it small int? Is there just a regular int?
There is int.
There's a lot of
Okay,
weird-
there isn't.
Small int would work as well, and if you're trying to like optimize and everything, you would probably do that, but I think for our purposes here, this is pretty good.
Now, what is the difference between integer and small int?
So small int is just a smaller integer, it's a specific, it has a specific length, like up to 5.
Is there any point to using integer for a small int?
I believe
over
when you use
regular?
a small int versus int, it saves you the smallest amount of memory in your machine. Okay, so where would be the primary key for the hero? So each table gets a primary key,
Okay,
so, yeah.
so this would be up here as well?
Yeah,
Just
you
PK,
can-
well,
you
it
could
still is
include-
an integer though.
Yeah, I would include both.
So, okay, primary key, I'm not really clear on that, can you
Cool.
kind
Yeah.
of describe what that is again?
So the primary key is a way to refer to rows in that column. And the primary key has to be a unique value, and so since IDs are always unique, usually set the primary key to the ID. So it's basically like when we join tables and do all these more complex queries, you do them on the primary key because it's very specific to what instance in that table.
Okay, so it's an individual ID for the table itself, it's the table,
It's for each entry in that table has
kind of a
its
stamp.
own ID.
Okay.
Right, and so if you wanted to look up a hero, a specific hero in that table of heroes, you can't really do it by the name or the level or the health, because those could all be similar to other heroes in that table. But the ID is gonna be unique, so if you wanted to look up a specific character, the primary key would be how you would do that, and that's essentially just the ID.
So you, I think.
It's the ID of the table.
Yeah,
Right,
no,
that's-
it's
the
like the
idea of the-
primary key, you can set it to, if you wanted to anything, like the name, anything, but like the ID specific, like there's not gonna be 2 1s or 2 3.
Well, right, I get that for each individual, but I mean, primary key as opposed to just ID.
Yeah,
The-
so we set
Okay.
the primary key to the.
So the primary key isn't necessarily specific to the table, but the rows in the table. So when we have 20 different heroes in our table, there's gonna be 20 rows, and these are all columns. And if you wanted to select a specific row, you would look it up by the primary key because we know it's gonna be unique. whereas the name and everything else can be similar. Does that kind of answer your question? Yeah. So we probably have a monsters table.
Okay.
If you want to pass the baton on at any point,
Anytime anyone wants to jump in, feel free. And it's
John?
So this is probably pretty much the same, right?
yeah, very similar to Heroes.
I think this is what we turn into popcorn, she can just say popcorn and
Yeah,
call someone else something.
totally do that.
Yep, anytime.
I think you holding the baton, aren't you the one that calls popcorn?
Yeah.
Oh,
You-
okay.
Or is it me?
Moderator. Brian, would you like to have a monster here with the heroes?
Not really.
Monsters, okay, well.
That's not how
I tried
popcorn works.
popcorn.
Popcorn.
You got chosen, you're chosen.
Alright,
You don't get
Brian,
to choose.
you're up, buddy.
You're up, sir. We'll help you out, don't worry.
Alright.
It's
Yeah,
really,
I-
yeah, it's not
pretty sure.
really
I
complicated,
didn't-
it's,
I didn't know.
I don't know.
No other mistakes.
we got the outline for you. Oh.
Oh, cool.
So what would be the primary key, Mr. Brown?
Don't look at what? Don't look at this stuff?
No, you can
We're
look
looking
at
at
it.
monsters.
Okay. Alright. Oh, I just kinda did it, so what do we do?
Primary key.
You wanna add the data types and primary key.
Are you recording this,
Just
Brian?
like this, right?
Well,
You can't edit this out, you're gonna post it.
I'm not gonna post it, it's for me. Everybody's gonna get mad, yeah. What do you want me to do? Just like,
data types and the primary key for the monsters
just
table.
like this? Like what she did?
Yeah.
Okay. What's the PK stand for? Primary key?
Yep.
Okay.
Cool, and we probably have a shop, right? Let's do a shop table.
Okay.
So what do you think would make up a shop? What's that?
NID, okay.
Yeah.
Yeah, I guess everything is kind of okay.
What do you typically like kind of get in a shop?
Is it the armor or what?
Yeah, armor, definitely a good column for a shop.
Okay.
Maybe weapons.
Health, more health.
Potions, yeah,
Potions.
that's good.
Weapons.
You might break those out, wouldn't you?
Well,
We're doing this different.
so I have a shop where you can purchase weapons, armor, potions, and then there's also an armors table and a weapon table as well.
So those would just be IDs.
Yeah, kind of like form keys.
Okay. So maybe say armor ID, potion ID, weapon ID, right?
Okay.
Yeah.
This was yesterday.
Is it camel case and,
Sure.
yeah, okay. Okay.
Cool, let's do data types and primary key for that table.
Okay.
Will we set the point keys there or on the weapon?
I was gonna get to that next, so keep going, you're good.
Okay.
So the next one I want you to create though is a armor table.
Oh, okay. So all these should be integers, right? 'Cause they're IDs.
Here, yeah, let's
You
do
tell
it.
us.
Alright, let's do an armor table. That'll hold all of the different instances or rows of all the different types of armor and, you know, their attributes.
Okay. Should I just go on the bottom somewhere?
Wherever's good for you. So
Okay.
maybe next to the shop would be good.
Oh,
If
okay.
they're gonna be closely related.
Cool. Put ID as well, right?
Yep, definitely gonna want an ID for every piece of
Okay.
armor.
Okay.
Maybe like cost, like gold cost.
Oh, yeah.
What do you guys think? Some other attributes for armor?
Absorb probably.
Minimum, maximum, like that.
Um,
Minimum
That's for
strength.
weapon, I think.
yeah, that
Was
would
it?
fit more into weapon,
Oh,
but
okay.
John brought up a good one, like an absorption
Absorb, okay.
kind of value, like how much damage it absorbs.
Also a name.
Name would be
Oh, yeah.
great. Maybe durability.
Okay.
That's a whole new dimension right there.
Okay, and then let's do the primary key and data types.
The shop chart with the armor ID, weapon ID, potion ID.
Cool.
Those are the foreign keys, right? We label them foreign keys like the other.
Oh, yeah.
I think that's a decimal.
Or don't, or we're just gonna count gold as whole numbers, you know? Or we're gonna break down to like actual money, we got all of it. What do you like, how many pieces of gold you have?
So for absorb,
Gold actually have a actual value.
probably gonna be a percentage, right?
Oh, sorry, it'll be.
Okay.
And since we don't really have a
Yeah,
percentage
because
data type, we could use a decimal and then later convert it to a percentage in
Okay.
some logic layer.
So decimal?
Sure, yeah, that'd be good.
So the only way you can use a decimal in these databases is to use decimal or strings like you were doing with the other one, but as an integer, we do
Is
a
that good?
decimal.
Yeah, if you wanted to keep it like numerical, you need decimal. So decimal takes two values essentially, or
Like this, like.
the first one
Yeah.
is gonna be the amount of digits to the left of the decimal,
Okay. Oh.
and the second value is the amount of digits to the right of the decimal.
So like maybe between the right and.
Probably zero, if we're doing percentages, wouldn't it be like 0, 3?
I don't know, like 100.00.
Yeah, actually, that's a good point. If we're gonna convert it into a percentage, it's usually a 0 point something decimal.
Oh.
Like 0.68 would be 68% or something like that. So you have the two, good. Just maybe change the first value to 0.
Oh, first put one right.
Or maybe 1,
zero
so you
right.
can include the 0, yeah.
And goes up to like what?
Maybe 4 even,
4.
3. Cool. So the next thing is, we want to, instead of ID, do armor ID on the armor table. And so that's gonna be our primary key for our armor table. But in our shop table, it is also gonna be a key, but what key do you think it is in our shop? See how they're the same? They kinda, those two columns kinda connect armor to shop.
Yeah.
So the first one in the armor ID, in the armor table is primary key.
Yeah.
Then in our shop, our armor ID, what do you think it would be? What kind of key?
So they're all gonna be primary keys or what?
No.
No.
Do you remember foreign key?
No.
Okay, so the foreign key is basically what
I already have like 3 matches.
matches the primary key in the
Just
table
one.
to a value in another table. So the armor ID would be a foreign key. in
So
the
I need to
shop
find
as
that
well.
just because I don't know.
Okay, so
Yeah, and then it gets him
okay.
later.
Yep.
That's
Perfect.
good.
Okay.
Cool. You wanna keep going, or you wanna popcorn?
Anybody wanna go up?
That's not how popcorn works. Popcorn. Wasn't going up yet. Yeah. Alright. So, we probably wanna do, maybe, oh, you're jumping ahead. Cool, I like it. What do you think, what's the next table you think you might wanna
Weapons,
include?
I'm guessing?
What?
I'm guessing weapons.
Yeah, that'd be great. Weapon table.
Down here.
So ID, primary key, weapon, gold cost, max, min, name. That's pretty good. Maybe durability, but I don't think we really need to go into it. But since we included on the armor, let's see if the weapon too. And then that's probably good on tables. I mean, we could do like a hero inventory table, but
You have the potions ID in the shop, we should probably have the potions.
that's true. That's true. Let's do that. Good point. And then next, and then before lunch, we'll just kind of wrap up the relations between all these tables. Fun stuff.
Good question. We've kind of, out of necessity, had to put databases kind of everywhere throughout the course of the cohort. So what we've learned with C# and Node, the last place we put our databases were in those files.
Mhm.
This is going to be another separate file. And C# and Node are ways to interact with those databases that are even further in the back for the back end.
Yeah, it's almost like here's your front end, here's your back end, here's your database over here, and you connect them with a connection string. So your back end will be connected to your database. It's almost like out from the full stack. I mean, it's part of the full stack, but you have to kind of connect to it. And all of this lives in the database, and you access all of it through SQL.
Okay. So those commands that we're using, the query type select and whatnot,
Yeah.
those, you wouldn't use those in C# or Node. You
Not
use those in
necessarily, no.
SQL.
It would be like its own file, like a query.
Okay.
So there are things called ORMs. I forget actually what the ORM stands for.
Cool.
An ORM is a much easier, nicer way. So with
Good
talking
job.
about the main stack, you have Mongo, which is your database. Then you have
Just one thing on the
Mongoose,
bar card
which is
is
your
you
ORM.
have a
And
link.
all Mongoose is an npm package.
Melon
Right?
Raspberry.
JavaScript code in Mongoose, like kind of the Mongoose way of writing JavaScript code, right? And you just kind of say, hey, I want these users, or I want a user based off of this ID.
In Node.
In Node, yeah, you write all that in Node, and then Mongoose would do the dirty work of taking your JavaScript code, turning it into SQL commands, going into the database, getting what you want.
So that's your $.sign scope for the back end. That's your bridge.
Yes. Yes. Fantastic analogy, yeah. So scope is the bridge between your control and your view. Your ORM is your bridge between your backend controller and your database. So I think it's link and right and yeah, like link, you write link commands in C#.
Okay. Yeah.
Which we haven't. I don't know if we've gone too deep into that with you guys yet. But we'll probably go as we get into the third project more and more.
Makes sense.
Okay, so probably the last thing before lunch, let's go over like relationships between these tables. Remember, there's one-to-one, one to many or many to one, and many to many. So, for game to heroes, what do you guys think?
One to many.
Perfect. And that's assuming we're in a like multiplayer video game. What about game to monsters?
One many.
One to many.
Or, is it many?
Well, one instance of a game to many monsters.
Can the same monster live in multiple games?
Thanks, Billy.
Oh, yeah. I would think it's many to many.
Yeah.
Blow my mind.
But we can think about it, like, if there's only ever one instance of a game, then yeah, it's one to many.
Let's do it.
How do you guys wanna go about it?
We'll go one to one, because I'm confused on what you, or one to many, because I'm confused what you guys are talking about.
Okay.
So you could
So
have,
I have, let's say we're playing like a silly Star Wars game, right? That game has instances of it, right? You're playing Star Wars on your computer, you're playing Star Wars on your computer, you're playing. But you're probably gonna be fighting the same monsters at some point, right? Does that make sense?
Oh, if we're talking like an MMO kind of game?
Sure.
Versus
Open
if,
world.
so if we're doing like
Or-
a single player,
Or just any kind of game. There's instances of that game, right?
well, like if I'm playing a single player that's not connected to like anybody else's game because it's only single player, then it would just be the one to monsters.
He's panning back a little bit,
I'm
like.
panning way back, right?
If I bought the same game, I'd
If
be
you bought
fighting
the same
monsters.
game, he's gonna fight the same monsters that you're fighting. But it's on his instance of the game. You have instance one, he has instance two. The game has instances.
But would that go back to a database if we're not connecting to the internet?
That depends, right? Yeah, it could be, if we're talking about console games, probably not. But if we're talking about like games that you can buy off Steam or something like that, yeah, probably.
and even a console game that would allow you to have multiple profiles.
There you go. Yeah, exactly. Like you can play it on easy mode and hard mode, right? There's like multiple instances of the game within the game.
So you guys wanna go many to many?
Sure.
Alright.
Let's make it difficult.
Maybe it could be the same for game to heroes, right? Many instances of the game can have many different heroes.
Now that Billy's totally changed the whole dynamic
Yeah,
of
he's
what we're
changed
talking
the
about.
physics of reality.
There is no right or wrong, right?
I know.
This-
It
this
depends
is
on the
Billy
kind of
playing
game you wanna-
God.
This is, yeah, basically.
No, it just depends on the kind of game you wanna build.
And also, we're kind of architecting our data model. It's kind
We're
of,
just giving you a hard time.
Yeah, I know you are.
it's kind of up to us how we want to architect the game if we're kind of designing the database, right?
Right.
Well, maybe not up to us, up to our boss, but.
But these are good, like, oftentimes your boss is not technical.
Right.
So he's gonna just say, I want this, and you're gonna kind of read between the lines and think through, like, and ask him the human non-technical questions, like, is this what you're thinking, or is this what you're thinking, to help you to understand, you know?
So heroes and monsters.
Well,
Probably.
it depends, like if it's just one person playing, it's gonna be one to many. Right?
Now we're getting to philosophy.
I don't know if they need to relate that either.
Many to many.
Yeah, it's actually a good question. Do they don't need a relation?
They don't need a relation,
Got it.
no. They relate through the game.
Well, what
that's
about
it.
if you're kind of trying to keep track of like experience points? Don't you need
Then a monster would have experience points, and upon its death, the hero's experience would increment by monster
Yeah,
experience
it's
points.
individual.
Okay, that's very valid.
But the relation would assume that like the hero now owns a monster, or the monster now owns a hero.
True.
But there's no couch that can, at least in the game that we built thus far. If we wanna build a different game, then sure, they can relate, right?
Okay, what about heroes to weapon?
Many to many.
One hero to many weapons? Cool.
I think,
Well, it depends.
let's think about it, what does one to many assume?
You can carry multiple weapons.
One hero can carry multiple weapons, so there's only ever one instance of that weapon then? I mean, that weapon would never, ever be owned by any other hero?
No,
Not in the
No,
same
it's not.
game.
Depends on
I
the
mean,
game.
not
No.
the same instance of that game.
Has anyone ever played Counter-Strike?
Oh, yeah.
Yeah.
Can only one person buy the Desert Eagle?
Well, in
Well,
our
yeah,
Everybody
RPG,
can buy the Desert Eagle, right?
Yeah, we're not playing CSGO.
So-
But I'm just
but
trying to give you
realistically,
examples of
we want-
what you're saying. If you say one to many, then only one person can ever own that weapon. But if you say
Well, it's
many
kinda
to
like
many,
with
then
your
everybody
heal
on the
potion,
team
remember
can own the
you
weapon.
bought it and then it was out of stock and you couldn't restock it? Wasn't that what it was?
Yeah.
You
Uh,
couldn't.
no, I
A
couldn't.
hero
couldn't
can have
load more
many
than one
weapons and
instance
one
of
weapon can have multiple
healing
heroes on
potion.
it.
It was tracking by ID, so
I would
I,
think-
so
I would
it
think
wasn't
Right.
tracking by
In most
ID,
games
so
that
it's
you're
saying
correct,
you
I
could
would
have
assume it's
duplicates.
many, yeah.
So once I tracked it by ID, then I could have multiple.
Well, it's kind of the same principle here, you know, we're talking about.
Unless there's only
weapons.
one-
Can
ever
only
one
one
instance of
person
that
own a
sword.
weapon.
Maybe there's a really rare, unique sword that only drops once.
Grinding time for it and sell it on Steam on it. I don't know, this stuff.
Okay, what about game to shop? Do we want multiple shops or only one shop?
One shot.
One shop? So what would the relation be?
One to one?
One to one, many to one? I'm just kinda taking a poll here.
How many
I'm gonna go
days?
many to one, cause it's many.
What's the
Many
context?
days, yeah.
With one shot.
I'm kinda thinking along those lines too, there's many instances of the game and we're saying there's only one shop in the game, so it's not many to one.
But would each instance of the game have its own instance of the shop for it to go to many to many?
But for a shop, there's only one instance of the game. Right, does that make sense?
So, many to one.
What about armored shop? Or, yeah, shopped armor, armored shop.
One to many.
Could it be one to one or one to many?
Well, is there only one piece of armor? So we go, one to many. Weapons to shop? Cool. Potions to shop? Yep. Kind of making a mess on this whiteboard.
And then who won't take this out?
We'll just leave it up and scare the part-time class tonight.
This is what.
And then we need to know weapons and armor of heroes and monsters to their respective areas.
Right. You guys think it'd be good to have a inventory table?
Yes.
Kind of like a bag.
Oh,
So I think this is, it's good to leave it up to the class, we gotta
Would
make it
it
as
be,
complicated as
for
possible, right?
monsters and heroes, would it be weapon or weapon ID to be able to upgrade?
Well, it depends if we're making an inventory bag, that could have the foreign key to the weapon ID, right? So let's make an inventory, or like a bag, or a chest, or, you know, whatever. We'll go over here. ID. We can go, weapon ID. Armor ID.
Or if you just have shop ID, because so I'm just trying to figure out what the difference is between shop, why would you not just add this to the shop? The shop includes armor ID, potions and weapons.
Right, so the shop is kind of where a hero would go to buy a piece of armor. And once he purchases it from the shop, he's either wearing it or it's in his inventory. That kind of makes sense?
Mhm.
So the shop is just kind of like a place to pick up new items. You don't really own the items yet, so you can't connect them yet. But once you have them, they can fall into like your inventory.
Then the inventory can have more than one weapon, right?
Yeah. Yeah, your inventory can have 20 weapons,
Then your
10
shop
armors.
is the actual weapon with the weapon ID.
Right, so then the hero's weapon would kind of swap back and forth, and you could have multiple weapons in your inventory, but maybe only one or two equipped.
I have a similar confusion to Alicia. In the shop, if we were to kind of flesh this out, the shop would look like just rows and columns of IDs or numbers. It wouldn't have names of anything or attributes, right? The shop itself.
It's really just kind of
Right.
two files removed from each other.
So the shop,
Temporary.
it will get all of the, you would probably do like a join query on something like a shop with armor, where you join the table from shop to armor ID, and then you would basically print out all of the other attributes of armor based on the ID in the shop.
Okay.
That kind of makes sense? I mean, the shop itself could have a name, like for the shop, you know, shop name. And maybe even like location on the map and some other attributes of its own.
The shop's just kind of a hub and it's gonna route you to whatever you wanna purchase.
Pretty much.
All
Yeah.
Temporary
join
holding
mapping
pattern.
tables or lookup
Yeah.
tables or. Their only
Like
job
C#
is to kind of like,
inheritance, it's like a-
help that relationship work.
Okay, so. Inventory, how am I on, how are we on time?
Almost there.
Cool.
Couple more minutes.
Cool. So
What do you mean, inventory? You would want to-
yeah, we would probably need an inventory ID. So that's inventory ID at the bottom, down here. And what would the inventory ID be a foreign key? Cause it's connecting two tables, right? Foreign key, and same with the hero, foreign key. And what about the weapon ID on the inventory would probably be a foreign key as well as all the other armor as well as potion. Foreign keys linking to the other tables. So then what do you think the relationship between the hero and the inventory is?
One inventory, how many heroes in there?
Well, can many heroes access the same inventory? Like what is the relationship between a hero and an inventory?
It's on a view.
What do you guys think? Many to many?
So,
One to one?
If you do one-to-one, is it that there's only one inventory per hero, or is it there's only, or that, there's only one instance of inventory?
So I think,
So can
I
you
understand
have
your
one
question.
backpack or two backpacks?
One backpack.
Or one hero.
So
Right.
One to one.
So how, yeah,
So it's,
Exactly.
yeah, so that was the question. If it's one-to-one, it's each hero gets its
Yes.
own individual.
Each instance of a hero has access to one inventory. And one inventory can belong to each individual hero. So it'd probably be one to one.
now let's say, let's throw a curveball, let's say if you belong to a guild, you all have access to a common inventory, right? There's 8 of you in a guild, and everybody has access in that guild to one inventory. How would that change?
Do you think everyone would have access to it, or only as like
Yeah, just like
guild
a
leaders?
community chest. Everybody can go into that community chest, how would that change it?
It's a
That would
boolean.
probably separate it into a separate database of a guild inventory.
No, it's just change the
No, it's
relationship.
just a condition.
Yeah, it'd be,
or
many
boolean
heroes
statement.
to one
Well, a
inventory.
hero would still have its own one inventory, so I think, don't you think it might be its own table, a guild?
Hero would then just.
I would just think one instance of an inventory can belong to multiple instances of heroes,
But
right?
then what about the individual inventory of each character?
Yeah, I think what he's saying, like, let's say that inventory was four million.
The other.
I'm throwing let's change the dynamic of the game, right?
So heroes don't have their own inventories at all anymore?
Right, that would be the idea.
Okay, like,
But, yeah.
like you just straight up don't have a person.
Don't have an inventory, the only way you get an inventory is by joining a guild,
Oh,
8
yeah.
people in a
then
guild.
it would-
That'd be nice and one.
Then it'd be one-to-many.
one to many, right? One instance of an inventory can belong to many heroes, multiple
Yeah.
people can kind of dive into this chest and put things in and out of it, right?
And And then if it were a second inventory for only when you join a guild, it would probably be a whole other table, like guild inventory. And you would have to belong to a guild table to even have a relationship to the guild inventory. So do you guys think there's any relationships that we're missing here? Probably the monster to weapon and armor. It looks also like
Hero to armor.
hero to potions.
We've kind of identified those already.
Yeah, it's gonna be the same as the weapons, the same as the armor, same as the potions.
Monster's
And
gonna drop anything, do it in inventory.
it would, huh?
But we kind of, I mean, that one really.
It's gonna be the same, I think.
Multi-party defined.
1-to-1. What do you guys think? Any questions? Any points where it's kind of confusing, or? I know it's kind of a lot all thrown at you.
Appreciate you explaining it, but for the lab, are we just gonna build a database like this?
Well, kind of up in the air. What do you guys want to do for a lab? Like, what do you think would benefit you the most? I was thinking like, just do like practicing our queries, having, I have a sandbox. It's basically an online sandbox where there's tables and you're able to run queries on the tables.
Yeah,
So
that's good.
I think that'd be good, but if you guys wanted to create your own data models of concepts, we could do that as well. It would just be separate labs, cause the online sandbox kinda has some restrictions.
Oh,
We can do both.
Let's start
Yeah.
with the,
sorry, people.
Yeah, let's start with the queries, that way we see immediate feedback
We see
on
any
how,
outputs, yeah, like
how accurately we're doing.
Cool. So the sandbox, I'll link it to you guys, when you get back from lunch or during lunch. It's a sandbox, you run queries, there's I think 4 or 5 tables, and you basically work within what they provide you. You can also insert stuff into their tables, so that's kinda cool. Yeah, we'll do that when we come back from lunch, say like 1:30.
Are these queries or tables? These are tables, right?
Those are all tables, yes
Okay,
sir.
okay.
And they're all in one database.
Alright, gotcha.
Yep.
As you can see, there's a lot of work that goes into this. That's why we kind of give you guys a full day to really think about your data model. Like, this is really what we're talking about at the end of the day. So if you're at a company or a startup from the ground up, like, this process could take weeks sometimes. Really thinking through every little, especially with like game design. Holy cow,
This is
there's
how the
so much
budget
that goes
goes.
into it.
Yeah.
It's like a whole separate job, just
Yeah.
data
Oh, yeah.
architecture.
I worked at the company I worked at, there were 3 people whose full-time job it was to just do our database, like manage the database and make sure that, and validate the data was going in and out of it appropriately, blah, blah, blah. Like, that's a lot of
So
work.
that's the bones of.
Later on, we'll be able to figure out how to input data from our, let's say, website into our.
Great.
Yeah, we'll probably go over how that works.
Appreciate it.
For sure. So yeah, and you should, we'll get more practice as you kind of dive into that third project, starting at the tail end of next week. This is gonna be a big part of it, right? Really sitting down and thinking through how all of this